If you mix baking soda, also known as sodium bicarbonate, with any acid, you can notice that a lot of bubbles are evolving. Effervescence is happening. If I zoom in, you can still see the bubbles coming out. Now this over here is carbon dioxide gas. And this is what we are going to talk about in this video. Basically, how metal carbonates and metal bicarbonates, they react with acids. So let's begin. So first, let's see how metal carbonates react with an acid. So for this, I'm going to take an example. I have sodium carbonate, Na2CO3, and I'm going to react it with hydrochloric acid, HCl. And this is going to be a double displacement reaction. Here, the ions are going to exchange position. And we have talked about double displacement in a separate video. So can you pause the video over here and try to think about what are the products of this reaction going to be? And if you have tried it, let's see. So see, when I mix sodium carbonate and HCl in an aqueous solution, that meaning in water, so from sodium carbonate, I will get sodium plus ion, positive ions of sodium, and carbonate minus 2 ions. Let me write it with the same color. Carbonate minus 2 ions. Similarly, from HCl, I will get H plus ion and chlorine minus ion. Now see, the ions are going to exchange position in double displacement reaction, right? So here let's say that the positive ions, they exchange position. So sodium, it was earlier attracted to negative ion of carbonate. But now it sees that, hey, chlorine is also available over here. That is also negatively charged. So sodium will now get attracted towards chlorine and form NaCl. So here we'll get sodium chloride as one of the products. And in turn hydrogen, it will get attracted to carbonate ions and we will get H2CO3. H2CO3 as another product. Now you might be wondering, Ram, you talked about that here carbon dioxide should be formed, right? But here I do not see any carbon dioxide on the product side. So what is happening? So see, H2CO3, this is not very stable. It is going to further decompose into water and carbon dioxide. And this is the carbon dioxide gas that gets released. So we can say that a metal carbonate reacts with an acid to give us salt. NaCl is a salt, right? Water and carbon dioxide gas is released. Okay. Now before we confirm this, let's look at one more example. So this time I'm taking calcium carbonate. Calcium is a metal and I'm taking its carbonate. And I'm reacting this with another acid, sulfuric acid, H2SO4. And this is also going to be a double displacement reaction. The ions are going to exchange position. So this time calcium, it will get attracted to sulfate ion and form calcium sulfate, CSO4. And hydrogen will get attracted to carbonate, okay, and form H2CO3. So this is going to be a product. And you know that H2CO3 is not very stable. It will further dissociate and give us water and carbon dioxide. Okay, so now we can confirm that a metal carbonate, it reacts with an acid to give us salt, water and carbon dioxide gas is released. Let me write it out over here. A metal carbonate reacts with an acid to give salt, water and carbon dioxide gases released. Now let's react metal bicarbonate or metal hydrogen carbonate with an acid. So for this, I have an example. I'm taking sodium hydrogen carbonate, NaHCO3, and I'm going to react it with hydrochloric acid. So this is also going to be a double displacement reaction. The ions will exchange position. Here sodium will displace hydrogen and combine with Cl, forming NaCl. NaCl. And hydrogen will combine with HCO3 and form H2CO3. And we have seen that H2CO3 is not very stable and it is further going to dissociate into water and carbon dioxide. So same products are formed over here also. So we can say that in general, metal hydrogen carbonates, they react with acid to give salt, water and carbon dioxide. Salt, water and carbon dioxide gases released. So we saw that in general, metal carbonates and metal hydrogen carbonates, they both react with acids to give salt, water and release carbon dioxide gas. Now let's look at the same thing in an actual experiment and see how to experimentally verify that carbon dioxide gas is getting released. So I'm adding baking soda or sodium hydrogen carbonate, NaHCO3, and I'm mixing that with an acid. Well, for my purpose, I'm using vinegar because it is an easily available acid. And now you can notice that there's a lot of gas that is evolving, a lot of bubbles are getting formed here. And we have seen that this gas is going to be carbon dioxide gas. But wait, how do we experimentally verify that this gas is carbon dioxide gas? Because see, this gas does not have any peculiar color. This does not have any peculiar smell also. And we know that there are many gases that are colorless and odorless, like hydrogen, oxygen, nitrogen. All of these gases are colorless and odorless and they are around us, right? So how do I experimentally verify that this particular gas is carbon dioxide? So see, for that we are going to do a lime water test. So for this, I'm going to pass this gas through a solution of lime water. By the way, in chemistry, whenever I say lime water, I do not mean lemon juice. I mean a dilute solution of calcium hydroxide in water. Meaning I'm mixing a very little amount of calcium hydroxide in a lot of water. That is called lime water. And you can see that lime water is colorless, just like water. Now when I pass this gas through lime water, you can see that slowly the solution is turning milky, right? And if I pass more and more carbon dioxide for a long period of time, then you can notice